operating system is a set of programs that control computer hardware and acts as an interface with application programs. Okay, so you all know probably what's the operating system your computer runs right now. Can you type in chat box the operating system you are using right now? Yeah, Shane is using Linux. What's your distribution there? So guys using Windows 10. Shane, you can be more specific, possibly. Do you use Ubuntu? Yeah, okay. Like we have many. Yes, thank you. So and then we may have also macOS users. Yeah, okay, Macintosh computers. So there are some operating systems. And then if you go even mobile, yeah, I said, what does this plus means? I hate when the kids are kind of posting plus. What's that? Like, can you please be specific? Possibly it's not match. It's kind of Macintosh. Excellent, yes. Mac OS, yeah, excellent. So Isel is using Macintosh computer, and then basically her platform is different from what Turgay is using, yeah. And then Hussein's platform is totally different. Maybe he runs his computer is running on the same CPU with Turgay, but he's using different operating system, and basically that's the difference between the platforms. Now, obviously, you would have different classifications of operating systems, like single computer with a single user, single computer with multiple simultaneous users, or multiple computers with multiple users, or special purpose computers. In fact, there is a correlation between this classification and the sphere of influence. But if we look at the operating system, simplified model of the operating system is it does look like that. So basically, this sandwich structure should be kind of familiar to you, yeah. But then you have the hardware in the kind of in the bottom. So this is hardware, yeah. But you probably know the word hardware drivers, yeah. Obviously, operating system has also a sandwich structure for a reason. Why is that? Because if you want your operating system to run on different hardware platforms, you actually need to have certain part which is hardware independent. And then if we oversimplify the structure of operating system, by the way, you will have actually a separate course, principles of operating system, where you will look deeper into the programming of operating system and then insides of operating system. But what's important, obviously, to run any program or to run your hardware, you need to be able to access certain specific devices which are specific standards. And then that's where you would need your hardware drivers. But some principles are independent of this hardware. And then basically the important notion in any operating system is kernel. So this is actually a word in English. You probably never heard. Did you hear the word kernel before? As a, not in IT understanding of the word, rather in normal human understanding of the word. If you didn't hear that, the kernel is basically like inside of the seed, in internals of a seed. Tum in Azerbaijani. Yeah. So basically, it's kind of core. Yes, core. Yeah. And then sometimes poetically people say heart of the operating system, yeah. But what's important, kernel has all this independently of the hardware, all this logic and all this functionality there, yeah. But to be able to actually operate on certain hardware, it would access certain hardware devices, yeah. And there is a mechanism actually for the operating systems to recognize what's the hardware which is it's installed on, yeah. And then kernel, yes, heart of the operating system or core of it, yeah. And then it controls the most critical processes of the operating system, and it ties all of the operating system components together. So basically, kernel is kind of connecting all parts of the operating system. Now, you would say, what are the most critical processes of the operating system? We need to quickly look at it, okay? It's obviously not exhaustive, limited list, simplified list of what operating system does, but what's that? It would control common computer hardware function. It would provide a user interface and input-output management. Basic, I would say basic user interface. Yes, basic one. Yeah. Something like, for example, you would be able to enter something from the keyboard or read something on the screen. Providing a degree of hardware independence, what's that? Thanks to the drivers, yes. Yeah. Managing system memory. So how do you write data to memory? How do you load something to memory? How do you unload it? Yeah. Managing processing tasks. We will talk a little bit about that because you can actually run several tasks or programs at the same time, or you need to actually somehow manage it. Providing networking capability. How would you ensure that you would connect to other computers? Controlling access to the system's resources and managing. So file management is very important part. So if you have storage, it's just bits. But then if you want to actually have more complex things to be done on your computer, you need to have some file system. So you would be able to actually store big chunks of data in an organized manner, and you would be able to name these files, yeah, and you would be able to organize a structure within which, like right now, we have very metaphor of our daily life. This is you probably heard this word metaphor, yeah. But this is what computer scientists use a lot when they design systems. So basically, if you look at our operating system, which are right now, we have graphical operating system with more visual interface, but users are very much like find it easy to work with this operating system, unlike the previous times. I mean, the 2 years kids, they would get the mobile phone and start working on that. For very simple reason, it uses simple metaphors. So you touch it, you move it, yeah. And then if you are grown up, you would see that your computer use metaphors like desktop, directories, files in the folders, yes. So this is something we've seen in our real life. That's why it's easier to understand. So managing files, file management system, yeah. And then just quickly going through each of them. So what's the common hardware function? Get input from keyboard or another input device, retrieve data from this, store data on this, display information on a monitor. This is basic of basics, yes. And then if you think about user interface, it is actually a generally user interface. And by the way, there is actually a whole field of human computer interaction in computer science. One of our graduates, first graduates, he's doing masters in human computer interface. So this is very important. There is lots of things involved in that, including also psychology and how humans are actually understanding the different interfaces. But you need to understand that in old systems you would have only command-based user interface. Basically, you would enter some text commands and you would get some output in form of text. But then right now we are enjoying lots of graphical user interface. You need to know this abbreviation, GUI, yes. The user would interact with some visual items on the screen, yeah, like icons, menus. So you would send the command not using text. Rather, you would use you would send the command using some clicks and moves and an interactive visual elements. You can even do the whole programming through that, but then we will come back to that later. But then still command-based user interface still available in any modern operating system. And then yes, obviously there are some modern natural language interfaces. Speech recognition is used there, etc., etc. Even there is a brain interface. Now, what's important? How operating systems are achieving this hardware independence, and then basically, you remember probably very first definition we had for the operating system, it says that it actually ensures that your hardware would do, or it actually coordinates all these basic of, activities on your hardware, but it also helps the applications of software access with access to this hardware through what? Through so-called APIs, or application program interface, or programming interface. They would. So what's that? It's actually libraries. It's kind of a standard, a set of programming instructions and standards for one software program to access and use the services of another software program. So through that, your operating system would give some function, would provide some functionality, so you wouldn't need to actually reinvent a bicycle when, for example, you want to draw a window on the screen. Instead, your application software which would you develop, it would access operating system's ability to draw something on the screen. So you will not about APIs, but modern days, even some application software provides API for other application software to use. So it's very useful for actually uh, for building a big software, yeah, and then being able to reuse some ready libraries is necessary basically for that. And from another end, you also have this uh, drivers, hardware drivers, which are actually helping you to forget about what is the specific underlying hardware, and then more focus on the functionality it should actually implement. Yeah. Yes. And then we talk about memory management. So basically, in operating system, yes, I mean it should actually help your other software, can be also application software, to access memory effectively. But there is also a nice notion of virtual memory, which is very, you probably heard this word. So it's when hard disk space is used to actually give you additional capacity if your RAM capacity is not enough. Okay, so if you remember RAM, I guess you remember, yeah, your primary memory, yeah, your memory. To be able to run any program, you need to load this to your RAM, and then to be able to actually process certain data quickly, you need to actually load it to your RAM. But then sometimes you may not have enough RAM, so there is actually a mechanism of virtual memory, which is using your hard disk space, which we remember it's bigger, it's cheaper, yeah, but it's slow. But still, if it is comparably kind of you know cheap and comparably speedy, you can actually use this mechanism to supplement your RAM and run bigger programs. Now, there are also processing tasks like operating system important, let's say, functionality, which helps you to actually run different tasks at the same time, or in parallel, or give the several users a chance to actually run certain tasks or programs on the same computer. So it's called multi-user, and then their names are very self-explanatory. So I don't think that we need to explain it a lot. So a multi-user, it's like very self-explanatory, two or more users to run programs at the same time on the computer. Multiprocessing is like supports running a program on more than one CPU. And the multitasking, in you have one system, but then you would allow more than one program to run concurrently. It's like you are doing your homework in Word application software, and then you are running also music in the background. Yeah. Right. Okay. So I think we are almost there. And there is also so-called multi-threading, which within one program, in single program, you can actually run several processes or threads concurrently. So to be able to do that, you you actually have some memory management or task management techniques implemented in your operating system. And then believe me, some years ago it was not available. So in old operating systems, you would need to actually run only one at one time. Imagine. And then some early mobile phones would have the same problems. Yeah, but right now everybody enjoys this multi-threading and multitasking. Okay. Networking capability, access, and it's about access is about like basically secure access. Yeah. And file management, it's very important. So how do you organize your files, how do you access them, etc., etc.